Hi, friends. Welcome back. I'm Mrs. Grady, and I'm so glad you joined me today. In our lesson today, we'll be solving division problems where there's a remainder in the tens and the ones. Here's what you'll need for our lesson today. Let's get started. Read the expression with me. 57 divided by 3. So let's divide 57 into 3 equal groups. Pause the video and use place value discs to represent 57 on your place value chart, and make space for 3 groups below. Then set up the division to get ready for long division, and then come on back and we'll work on solving the problem together. Let's start by dividing the tens. Why should we start by dividing the tens? Pause the video and explain what you're thinking. You may have said that we should start by dividing the tens because when we divide, we always start with the largest unit. Or maybe you were thinking that we should start by dividing the tens because later on, we might have to rename some tens as ones to continue dividing. So it just makes sense to start with the tens. So 5 tens divided by 3 groups. Let's distribute the tens that we can and cross off the tens that we use. So we had 5 tens to share equally with 3 groups. How many tens are in each group? 1 10 is in each group. And do we have any tens remaining? Yes, we have 2 tens remaining. Let's show that same thinking in our long division. We have 5 tens divided by 3 groups. Gives us how many tens in each group? 1 10 is in each group, so we can record 1 10 in the quotient. Now we shared 1 10 with each of the 3 groups. Say a multiplication sentence that tells us how many tens we shared all together. 1 10 times 3 equals 3 tens. So we had 5 tens to share, we shared 3 tens, and we have 2 tens remaining. Say a subtraction sentence that tells us that. 5 tens minus 3 tens equals 2 tens. Okay, so should we stop dividing here or should we continue? And how do you know? Pause the video to explain your thoughts. Hopefully you said, we're not done dividing yet. We can rename these 2 tens as 21s so that we can continue dividing. So let's do that. Now, how many ones do we have to divide? Well, we had 7 ones already. And when we put that with the 20 ones that we just renamed from the 2 leftover tens, 20 plus 7 makes 27 ones. So we have 27 ones to divide. Let's show that same thinking in our long division. Here are the 7 ones that we already had in the original whole, these 7 ones here. And when we put these 7 ones with the 2 remaining tens that we renamed as 21s, that makes 27 ones that we have to divide, just like we see here in the place value chart. So 27 ones divided by 3 groups. Think about your threes facts. What is 27 ones divided by 3? If you're not sure, remember you can skip count by threes to find out what 27 divided by 3 is, or you can pass out 1 1 to each group at a time and cross them off as you go until you can't pass them out equally anymore. So pause the video here and distribute the ones and cross off the ones you use. So how many ones are in each group? 9 ones are in each group. And did we have any ones remaining? Nope, we used all of our ones. We have no ones remaining. Let's show that same thinking in our long division. We had 27 ones to share equally with 3 groups. How many ones are in each group? 9 ones are in each group, so we can record 9 ones in the quotient. We shared 9 ones with each of 3 groups. Say a multiplication sentence that tells how many ones we distributed altogether. 9 ones times 3 equals 27 ones. So we had 27 ones to distribute, and we distributed all 27 ones with no ones remaining. Say a subtraction sentence that tells us that. 27 ones minus 27 ones equals 0 ones. So we have 0 ones remaining. And so what's the quotient? The quotient is 19. Say the whole division sentence. 57 divided by 3 equals 19. And how can we check our work to this division to make sure that we divided correctly? We can multiply. We can multiply 19 times 3. So let's do that. When we multiply 19 times 3, our product is 57, which is the whole amount that we were dividing, so we know we divided correctly. Nice work. Let's try another problem. But notice this time, I don't have the place value chart. We'll still use place value language as we divide, but this time I want you to try to visualize in your mind the place value chart and those discs instead of actually drawing them. Okay, so read the expression with me. 86 divided by 5. Let's set this up for long division. 86 divided by 5. So we're thinking about dividing 86 into how many groups? Into 5 groups, 5 equal groups. So what's our first step? Pause the video to explain what we should do first. Did you say we should start by dividing the tens? 8 tens divided equally by 5 groups. I can picture those discs in my mind, and I know that we can put 1 10 in each group, and there would be 3 tens remaining. Pause the video now, and in the long division, show the tens that are distributed in the groups and the remaining tens, and then come back and we'll check. Welcome back. Here's what your long division should look like so far. We had 8 tens to divide equally with 5 groups. We can put 1 10 in each group, so that's this 1 10 here in the quotient. Then 1 10 times 5 groups is 5 tens. So that means we used 5 tens so far. We had 8 tens to distribute, and we used 5 of them already. And now we have 3 tens remaining. 8 tens minus 5 tens equals 3 tens. So we still have 3 tens to distribute. Now, what's our next step? Pause the video to explain what we should do next. Well, if we were actually drawing the discs in the place value chart, our next step would be to unbundle these 3 tens, and so we would have to draw 30 ones. That would be a lot of ones to draw. Here in our long division, we just imagine unbundling those 3 tens as 30 ones, and we rename them as 30 ones in our heads. And we put them with the 6 ones that we already had, and we get 36 ones that still need to be divided. So we still have 36 ones to distribute. Pause the video now and continue dividing. Divide the 36 ones into the 5 groups and finish out the division. Then come back when you're ready to compare your work with mine. Welcome back. Let's talk through how we continued dividing. We had 36 ones to divide by 5 groups. That means we could have 7 ones in each group. So we record 7 ones in the quotient here. 7 ones times 5 groups is 35 ones. so that means we used 35 ones. We had 36 ones to distribute, and we used 35 ones. 36 ones minus 35 ones is 1 1, so we have 1 1 remaining. So what's the quotient and what's the remainder? The quotient is 17 and the remainder is 1. So how can we check our division? Well, this time, since we have a remainder, we can use multiplication and addition. We can multiply 5 times 17 and then add on the remainder to that product. So let's do that. When we multiply 5 times 17, our product is 85, and then we add on our remainder of 1, and we get 86. Since that's the whole amount that we were dividing, we know our division is correct. Nice work. Let's try another problem, but this time we're going to solve it a little bit differently. Sometimes when we need to divide a number into equal groups, we don't have to use long division. We can use mental math because sometimes that can be more efficient. For example, look at this expression, 74 divided by 8. If I use my basic facts, I know that 74 is not going to divide equally by 8. So I'm thinking of an 8's fact whose product is close to 74, but not more than 74. Can you guess what fact I'm thinking of? I'm thinking of 9 times 8 equals 72. I can show what I'm thinking using a number bond. The whole amount that we're dividing is 74, and I can pull out as many groups of 8 as I can, and let's skip count by 8s to keep track of how much we've pulled out so far. Ready? 8, 16, 24, 32, 40, 48, 56, 64, 72. Can I pull out any more groups of 8? No, there's not enough left. So how much is left? 2. There are 2 left, or 2 remaining. So we pulled out 1, 2, 3, 4, 5, 6, 7, 8, 9 groups of 8, just like we saw here in our basic facts, and we have 2 remaining. We can show that thinking more efficiently like this. 74 is the whole amount that we're dividing, and since I know my basic facts, I can pull out 72 all at once because I know that's 9 groups of 8, and then I know that I'll still have 2 remaining. So if we have 74 divided by 8, what's the quotient and what's the remainder? The quotient is 9 and the remainder is 2. Nice work. Let's try another one. 87 divided by 9. Think about your 9's facts. What 9's fact would give us a product that's close to 87, but not more than 87? 9 times 9 equals 81. So if 87 is the whole amount we're dividing, we can pull out 9 groups of 9, which is 81, and then how much of the 87 is left? 6. So 87 divided by 9, what's the quotient and what's the remainder? The quotient is 9 and the remainder is 6. Excellent work today, friends. I think we're ready for the problem set. On the screen are the must-do problems for the problem set. Set a timer or watch the clock for 10 minutes and work on these problems. If you finish early, feel free to work on any of the other problems as well. Today, we solved division problems where there was a remainder in the 10s and in the 1s. Be sure to check in with your teacher, and I'll see you next time for another Eureka Math lesson. Bye!